All right, today I need to finish up parametrics, and I know that sounds crazy, but this is the second day. It's a 2-day long unit. The second day of parametrics, and then tomorrow's review, test Thursday. All right. So I need to cover everything that we covered yesterday just super fast because I got to cover everything else today. So here's yesterday. You got introduced to these guys. And they were a system of equations that also had a domain. The domain, by the way, is usually like 0 to 1 or 0 to 2, but it can be like -1 to 1, so I'm going to throw that at you. It can be, because time, t isn't always time. Time can be the t, but t can also be an angle. And usually that happens if this is like sine or cosine. Okay, one thing at a time. Yes?
Wouldn't it be less than or greater than
Oh, or equal to? Yes, most of them that we do are going to be like, oh, whoop, sorry, like this. You are correct. I will change it to that. Even though I could set the domain the other way, it's not likely I would. Okay, so then you should be able to make a TXY chart. I hope this goes really fast. Would you please put in -1, 0, and 1 for the times and see what you get for your x's and your y's. I'm going to pause for a second while you review the most basic of yesterday's stuff. After you have made your little points, typically we would graph it. We are going to save time today. I'll graph it. It'll go really quick. All right. When you put in -1, I hope it went like this. And you should have said you got -2 and 6. Raise your hand if you had -2 and 6. Okay, awesome. And then the next one, when you put in a 0, you would just end up with 0 and 7. And when you put in a 1 in these two spots, +1, +1, you should have had a 2 and an 8. Raise your hand if you got those points, same as I did. Okay, awesome. Then do you get this is not a line in the sense that it goes on forever. This is only a line segment. It's a line segment that goes from -2, 6, which could be like there, 0, 7, which could be like there, and 2, 8, which could be like there. And look at that, straight line. How could I have known ahead of time it was going to be a straight line? There was no squares. If there had been a squared here, then you'd probably have had a curved line, if either one of them had been squared. Okay, and then last point, it needs arrows on it. How many of you remember to put the arrows on it? It's easy to forget. And then the other thing it needs, t equals -1, t equals 0, and t equals 1. And that's what gives this an extra punch compared to a normal graph. Not only it's got direction, but it also has a start and an end and the time it was at each spot. That's better than a normal graph. A normal graph would only have these 3 dots, and you'd know, oh, I know an x and a y. Here you know an x and a y and a t. And you know where it was at certain times, and you know where it started and ended. Okay, let's say we're going to make the same exact line, except in rectangular. Do you remember there was a 3-step process? Number 1, you solve each of the equations for what? T. They don't all have x or y in them, but it's safe to say they all have a t in them. Solve both of those equations for t. Take a second, do it. Solve for t, solve for t. Easy, super easy algebra. It's just a little tiny part of this. Solve for t. I'm going to clean this up for a sec. Okay, you should have divided by 2, and you have x over 2. And then you should have subtract 7, and t equals y minus 7. And since t equals the one thing and t equals the other thing, they equal each other. X over 2 equals y minus 7. And a typical equation gets solved then for y. Raise your hand if you had that right. Awesome. Does it need a domain? I bet a lot of people forgot the domain. The domain is this. You can't just copy that down there because it doesn't have any t's, so that wouldn't make any sense. Hello, sir. You want to chat for a second? Or you just, all right, you're welcome. Stop by the fan if you'd like. Okay, so let me see. We have our t has to now be changed to an x. Why x? Well, because x is the standard thing for domain. All right, these guys are the ones that have to go take their AP test now. Good luck. All right, is there anybody else who's leaving later to take a different AP test? All right, do you also need to go? All right, I understand. Okay, so how do I get the domain? Domain is an x thing. If I have an x and I say it's between a couple things, then what are the things it's between? How did you know that? You got it. And therefore, the lowest to the highest, that's like what the domain is. Very nice. So it's -2 to 2. And I should put an or equal there. Does that make sense so far? All right. And you got that was the beginning of this. That wasn't the end of parametrics. That was the beginning of parametrics. How could we have made this problem harder? What would have made it just more twisty? Yes? Having a squared in it. Let's say it had a squared in it. Do you know how to solve something like y equals t squared plus 7? Would you please solve that for t? It adds one little complication. Everybody knows how to subtract 7. Everybody knows how to take a square root, but then there's a little piece that everybody forgets, including you. Including you. Ooh, you think you remembered. Including you. Oh, everybody forgets this. Ooh, there's a good one. Right so far. We'll do the next piece. All right. We'll see who remembers it and who has to do the facepalm. Y minus 7 is equal to t squared. Square root, square root. We're all good so far. And then here's where we separate into two camps. Some people will just do this. Well, so t equals the square root of y minus 7. What's wrong? Has to be plus or minus. And it's so easy to forget. And can't we just kind of ignore it and act like it's not like a real answer? No, you need both parts. So we have to have t equals negative root y minus 7 and t equals positive root y minus 7. There we go. So yeah, you end up with two equations for just one equation. All right, so that's one complication that we have to be able to handle. Here's another one. What if I start with a regular equation and I want to make it a parametric? Wait a minute. Didn't we always start with a parametric and make it a regular? Yeah. So do you think there's a chance that vice versa would be fair? Okay. Well then, tell me this. What does a parametric equation have to have in it? Give me something it has to have. Okay, like what? Like a what part and a what part? God, he can do this all by himself. Don't listen to them. What does a parametric have to have in it? It has to have t's in it, yes. And you mentioned two what's? Two equations. So I'm going to say, what does one equation have to be about? Yes, we have to have a y equals equation, and it has to have a t in it. And we have to have, and it has to have a, all right. And then what last piece does it always have to have? A domain. And the domain is always a what domain? T. There. That's kind of your generic, they all have that in it. I mean, it might be more complicated, like 2t squared plus 3 or whatever, but it has to have a y equation, an x equation, and a domain. All right, then one more thing I'd have to tell you. This, if I didn't say the domain, you'd have to know what the domain was. Does a parabola naturally stop anywhere? Or does its domain go from -infinity to +infinity? It's negative to +infinity. Okay, so If this parabola has no domain, well, that means everything works, right? The domain is all reals. Okay. Well, then the time would never stop. The t wouldn't have a domain either. So that would actually be a little too easy. So I'm going to give you some points. If I put in 0 for x, I would get 2 for y? Would you agree this will go through 0, 2? Then I'm going to say it starts there, and it goes to, if I put in a 1 for x, I would have, do it in your head quick, 8. Then that's a part of the parabola. Do you get we don't really do this in parametric, so you don't like go forever. They start somewhere, they end somewhere. They have like time 0, it's here, and it's like a part of the parabola, like from here to there. We'll have a start and an end spot like that. All right, so then here's our start spot, here's our end spot. Generally, I know you know that parabolas kind of look like this, and this one just happens to start here and end there at 1, 8. So this part doesn't exist. It's just part of a parabola. Do you think you might be able to make a parametric for that? Sure you could. So yesterday you learned how to take a parametric and write it in rectangular. Now I'm giving you a rectangular, and let's see if we can make it into a parametric like this. So here is the thing. Repeat after me. X equals t. There, you've done it. Because from that, everything else will flow. I want you to think about that for a moment. I already had a y equation, didn't I? And if x equals t, what's my equation now? X is t, so 6t squared plus 2. And if x equals t, then x equals t. Huh? See the logic in that? Okay, and then how about t? What's my t domain? Since x equals t, then 0 to 1, because those are the x values. Does that follow for you? Since x is t, I could kind of like say that's x, except I don't want to write that in a parametric. I should have a t domain. So then it's 0 to 1. All right, so that's the first new thing for the day. I give you an equation, and you make it into parametric. Is this a parametric? Absolutely. If I didn't have so much to teach right now, I could go and make a TXY chart and prove to you that this would be on the TXY chart and that would be on the TXY chart, and it all works. It's perfect. All right, so let's make another one. You ready? I think you need to do this from beginning to end. Y equals 6t minus 5. Nope, that would be too easy. This is a rectangular equation, and it could go from 1, 1 to 3, 13. Then you make me a parametric. Pause for a moment while you give that a shot. In a moment, you're going to have a partner, because we're going to take a little partner quiz on paper, and hold your breath here. This is called a worksheet. You've never had one before in this class. It's always been on the iPad. You have a worksheet for homework. Isn't that weird? This is, back in the day, this is what you had often. But now we pretty much do them all digitally. So in a moment, you'll be putting your iPads away. Not yet. And you're just having a worksheet for homework. Just a worksheet. And that means if we do Dropbox it, I'll have you take a picture of it and Dropbox that. But one thing at a time. Worksheet coming to you in a moment. So you need a partner so you can at least check with your partner and see if you guys get the same answer for this. These two rows slide next to each other. These two rows slide next to each other. Could you move up here? These two rows slide next to each other. could you please move up here? I need another desk. We'll do this. You slide over, and he needs a partner. And I'm giving you a partner. Come on up, Mr. D. Slide over a smidge. There you go. Okay, and Mr. EL, could you come up here? Okay, so your job right now, try to write a parametric equation for this. And remember, what did I have you say after me? Repeat after me. X equals t. All right, there you go. I'm going to pause for a moment, see if you can figure this out. Okay, this is supposed to be the easy part. X equals t. And therefore, x is t. So that means that's 6t minus 5. And then I just have to have my domain in t's. They used to be in x's, right? So it was 1 to 3. And x equals t, so it's kind of like x is between 1 and 3, except it's not x. It's t. There we go. Raise your hand if you had that one right. Awesome. Now, see if you can handle it. Oh no, you did it differently. Now I cannot function. Come on, you can do this. Would you agree that's rectangular? I will give you this hint. Repeat after me, x equals t isn't always the case. I'm going to pause for a moment while you figure this one out. Oh, wait a minute. I got to give you some points that it goes from. We're going to say it goes from 0, 0 to 4, 1. That's a 4. 4, comma 1. Pausing. Okay. Hope you figured out from my little example that you must set y equal to t in this case. X equals t isn't always it. Sometimes it's y equals t. So, you knew that, didn't you?
Yeah.
Daywalker?
He was on the right track.
All right. Anyway, y equals t, x equals, what's that? 4t squared. There we go. And then, t, I know a lot of people are going to think that it's from 0 to 4, but no. Why not? Because x equals t. No, y equals t. So this is like a y right here. And so what's y between, because y is t, right? So what's y between 0 and 1? And therefore 0 and 1, but it's not really y, it's t, and there you go. Are there other ways to do the problem? Yes. Unfortunately, with the amount of time we have, I don't have time to explain all the different ways you could have done that. But I would suggest if they give you a y equals equation, set x equal to t. And then if they give you a x equals equation, just set y equal to t. All right. Next. All right, so here's the last melon. What if I said 1 comma or 0 comma 1 to 5 comma 9? In the old days, on the top 20, you would have been able to make, y minus y sub 1 equals m times x minus x sub 1. I wish I had time to do that right now, but we don't. So what do you think is going to be different? We're not going to make it rectangular. What do you think we're going to do? We're going to go to parametric. So how do we make a parametric for this? Well, a parametric for this, first of all, I would need to know one thing, and everybody start with this, right? T equals 0 under this, and t equals 1. Is there any reason that t has to be from 0 to 1? No. But don't use your empowerment to make your life complicated. If you could say that it takes 5 seconds to get from there to there, it's going to make your equations and your tables much more complicated. So always, when you're given a choice, which you are, always pick between 0 and 1. Okay, so if it's time 0 and time 1, then could I, any suggestions? Well, first of all, let's go back to what does a parametric look like? Would you agree as an x equals equation with a t in it? Something t. There's going to be stuff around it, right? But there's going to be a t over there. And would you agree there's also a y equals equation that also has that t in it? And then what does it need at the end? A domain, which will have a t in it. And ooh, I already know that one. Do you know that one? Well, look, we just picked it to be 0 to 1. I know that part at least. Okay, then how do you do the other part? I'm going to save you some time of guessing and checking your way to figuring out what the heck you put for this. I'm going to help you focus on the x's by eliminating my y's. Would you agree I have a 0 and a 5? I need this equation when I put in times 0 to come out with a 0. And when I put in for this, for the other part, when I put in time equals 1, I need the x equation to give me 5. So here's how you do it. This is like a slope and a y-intercept. Oh, you figured it out? What is it?
So when x equals 0 equals 5, and at the end of the equation it's going to be plus 5.
Because when this is 0, it needs to be 5.
Yeah.
Okay, wait a minute. Doesn't it, when it's 0, it doesn't need to be 0? You were really close. you had it backwards. You're really, really close, though. Okay. I've got it. No, it's completely backwards. But actually, backwards is actually really close. All right. So it's going to be a 5t plus what? 0. 5t plus 0 is the same thing as 5t. I would agree. But the reason I'm putting it this way is because I'm going to say this. Words to live by. Starting number here. Change here. That's like the slope. Remember, thought of the slope as a change? Change is from 0 to 5. So the change there is 5. Now, since I wrote it that way, you should be able to, now that I reveal what our y's are, 1 and 9, you should be able to write the equation for that with a t, with a little slope, and a starting number. Confer with your partner, see if you guys agree. All right, PR. Explain how you could prove it if the kid was like, I don't think that's right. The difference, how much the change was, you mean? Change? I agree. The starting number goes here, and that was the starting number. Very good. Okay, do you get how we wrote a parametric? If I needed to know if I was right, if I needed to check myself before I wreck myself on the test, and there's only a few problems, like there's only a few R3s, wouldn't it be smart to make a TXY chart and make sure it actually worked? If you did that, think about this. Do you get, when you put in time equals 0, you better get what point? 0, 1. And when you put in time equals 1, you better get 5, 9. Get what I'm saying? And when I put in a 0 into this equation, I get 0 and 1. That's what I was supposed to get. And now I'm going to put in a 1 in my equations, and I put a 1 here, and I get 5 plus, or 5 and a 9. Sweet. That's what I wanted. I know I did it right. Okay. You now know everything. Congratulations. So, one last one that just stumps the heck out of people on this worksheet. Let me give you this one, another one like this, just to remind you how this worked again. Let's say I gave you, wait, it would have an X in it, sorry. I already made the substitution, which you'll eventually make, but let's say it was like this. Repeat after me. X equals T. Okay, and then, cool, it's done. I've already got it, and that's it, and it's right. because they have a y equals equation. I can just set x equal to t. But what if it was like this? Oops. Ah. There. Did I give you an x equation?
What is
Or did I give, that's a 14, obviously.
like a 1y?
There we go.
So, did I give you an x equation? Did I give you a y equation? No, but I could make it into a y equation, couldn't I? Or I could make it into an x equation, couldn't I? So I either could make it into a y or an x. If so, I'd default to y. And you make it a y equals equation, and I'll save you some time. It's like the square root of 14 minus x squared. But then, wait a minute, I did a square root. What happens? Plus and minus, very good. Okay, so I'm not doing this the whole way because one of these is a quiz question on the little sheet that's a formative that you're taking home tonight. Answer key will be posted, so it's not like a normal formative. But it's kind of the stuff you need to know. So it's a great, great tool. All right. So again, I'm going to slap it in there, I guess. Okay, fine. So now I got a y equals equation. Now I could set x equal to t, and then I'll have the beginning as my parametric. And then I just got to remember, oh, wait, I must have points that it goes from. Would you agree that I could have some points here to some points there? They'll give you those. And then if you decided to make x equal to t, then your domain would be your x's. If you decided to make y equal to t, then your domain would be your y's. All right, so enough ado. I'm going to pause for a moment while we get these quizzes handed out to you. And the one I just give you a hint on, that was number 6 on the worksheet you're about to receive. Okay, so let's do a quick walkthrough of your in-class quiz / homework. There's the 12-minute warning, which means we should be starting this. Number 1, listen up. You do not get to pick what t equals here. They've told you what the domain is. And remember, if they start with y equals blah, 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 then repeat after me. X equals t. That is your hint for number 1. You have a question? Okay, sorry. I'll bring those back there. So on number 1, x equals t is a really good start. Moving on, look at number 2. On this one, this is the kind where you do not have time associated. You could pick anything. So when given the choice of any time options, pick t equals 0, t equals 1. Very good. Do that on number 2. On number 3, that's the one I even started with you on the board, except I used 14 and they used a nicer number. All right. On that one, that is not a directed line segment, so you don't get to pick the time. See, once people start picking the time, like t equals 0, t equals 1, they think they have to do that on all the problems. No. Only if it's a directed line segment. On the other kind of problems, it's just part of a rectangular graph. And hashtag #MoRealistic is like, you know, like that's the kind you'd actually have to know how to do for sure. Number 3, that'd be like a really hard R3. Okay, flip it over. Let's look at number 5 together. On number 5, what is it even? Is it parametric or is it rectangular? Is number 5 parametric or rectangular? It's parametric. And what does it want you to do? It wants you to make it with x and y, which is rectangular. You remember how to make them rectangular? Does it even say to graph it? No. I still might pull out the XY table, though. Sorry, the TXY table. You know why? Helps you with the domain. So even though you don't have to graph it, I'd still use the TXY table. All right, now look at number 6. On number 6, cross off your domain and range. On number 6, those might confuse you royally. The domain and range on number 6, think of it as a Genius Kid test. Can you figure that one out? All right. Number 7, it is actually to graph it, which again, of course, means TXY chart. And number 8, I got asked about this kind. I'm going to help you with one of the numbers on the chart for number 8 because I never got a chance to actually do one like that. And somebody asked. So everybody look at number 8 with me, and I'll start it with you. We need a TXY chart. So while I'm copying this down, start writing your TXY chart. All right, and then it's got a domain of pi over 2. Now, if it's your TXY chart, you can pick any angles you want. But this is going to be my TXY chart, so I'm going to tell you which ones I'm going to do. You can do others. But from pi over 2 to 2 pi, kind of a big range. I'll do pi over 2. That sounds like something I could do. Is it one of the ones I have memorized? Yeah, that's a 90-degree angle. So it's asking me to find cosine of 90, times it by 8, and add 2. Yes, you have to mix your like old stuff with your new stuff. Now, all you really need to do is cosine of pi over 2. Do you remember how to do cosine of pi over 2? I'll remind you what it looks like. Here's where pi over 2 is. On this kind, can you draw triangles? No. So you have to know what point that makes. At pi over 2, on the unit circle, that would be over how far and up how far? What, comma, what? 0, comma, 1. And now that we've got that, do you get, I could easily get both cosine of pi over 2 and sine of pi over 2. If you remember that sine's y, and that makes cosine what? So this part is the cosine. This part is the sine. And so when they ask me for cosine of t, and t is pi over 2, they're asking for cosine of pi over 2. Cosine of pi over 2 is the x part of it, and so therefore it's 0. And then you stick in a 0, and you go 8 times 0 is 0, plus 2 is 2. Get how I did that? Now, try doing sine of it. Sine of pi over 2. Sine of 90. Oh, sine's the y. It's 1. Stick a 1 there. 3 times 1 is 3. 3 plus the negative 1 is 2. Ooh, look at that. I got my first point. That's how you do that kind. Okay, now you got to pick some other angles. What's the next logical one between pi over 2 and on its way up to 2 pi? Well, here's pi over 2 and here's 2 pi, and they're saying basically any angle in between there, and you just pick a bunch of them. So how many do you have to do? We'll tell you on the test. I would pick things like things that you can do easily, like this spot would be pretty easy, wouldn't it? That's pi, right? And you know what that point is, negative 1, 0. And then you could pick that spot, and then how about in between? Could you pick that spot? Yeah, you could, because it's a bunch of pi over 4s. 3 pi over 4, very good. That'd be a good spot to pick. Anyway, you can pick what you want, but pick things you know how to do. And yeah, you'd have to figure out what sine of 3 pi over 4 is. So circle trig comes back again. Chapter 12 was a big deal. All right. Question for the... All right. On a test, we would tell you here, I would say at a minimum, you should at least do 1, 2, 3 more points. Does it say on the directions how many points to give? Oh, pot at least 4 points. Yeah, so I've done 1, and if you did these 3 more than that, you would have a total of 4 points. So there's your help on question 8, and that's all I have for you for this.